Hi, class 8 and 9, especially 7 also. You need light. Today I am going to say something about light, part 1 in Nepali, Prakash. The main objectives of this lesson are as follows. What is optics? Systematic study of light. Mirror. What is a mirror? How many types of mirrors are there? Uses of mirrors in our daily life for practical purposes, for street as reflectors, for saving, as a looking glass, etc. We use mirrors generally daily in our daily life. Refraction and laws. Along with reflection, laws of reflection also, which I will write down later on, laws of reflection of light and laws of refraction of light. Refraction through glass lamp. Logics, scientific reasons. Images formed by convex mirrors and concave mirrors. And not after writing the images formed, you have to write their nature, position and size using ray diagrams. Differences like difference between concave mirror, convex mirror, real image, virtual image, reflection, refraction and others. Question number 1. To help to study this chapter, I will write some short questions and long questions. Define light and optics. In lower classes, you define light in this way. Light is a form of energy which gives the sensation of vision. That is also correct. But here, light is an electromagnetic transverse wave which produces the sensation of vision or sight to eyes. It means light is a form of energy which can travel even through vacuum, solid, liquid, gas. Through vacuum, it travels at a speed of 3 lakh km per second. In glass, about 2 lakh km per second. Transverse wave, longitudinal, not longitudinal, electromagnetic transverse wave, which produces the sensation of vision or sight to eyes. What is optics? Optics is the systematic study of light, behavior of light, what properties are shown by light, what type of light is this, and what are the uses, etc. Question number 2. Define a mirror, classify it. A mirror, in Nepali we say oina. A mirror is a transparent, reflecting medium. There are mainly two types of mirrors. Mirrors type, mainly two types. Plane mirror and spherical mirror. Plane, सीधा यस्तो खालको. Spherical, made of a sphere. This is a sphere. If you cut sphere, you can cut one part of the mirror either in this way or in this way. Spherical. Spherical mirror, a part of the sphere. Plane mirror. A plane mirror forms virtual, erect and same sized image. Object up, image down. Object down, image up. Object left, image right. And object right, image left. अथवा object माथि by तल, image बन्छ left by right, right by left. यसरी जान्छ. Spherical mirror is also of two types. Concave mirror or converging mirror. A concave mirror is also called a converging mirror because it converges parallel rays of light to a focus. Convex mirror is also called a diverging mirror because it diverges the parallel rays of light, which I will write down in scientific reasons. Question number 1. Question number 2. Let me draw a glass slab. But before drawing the glass slab, you have to know laws of reflection and laws of refraction of light both. Question number 3. Write 3 laws of reflection of light with ray diagrams. 3टा ल हुन्छ. फर्स्ट र सेकेन्ड ल थर्ड ल यसलाई रे डायग्राम सहित यसमा लेख्नु पर्ने हुन्छ. रे डायग्राम सहित. सी फर्स्ट ल सी यसरी आइरहेको लाइट के होला त? यसरी आयो भने यो 90 डिग्रीमा आयो भने 90 डिग्रीमा फर्किन्छ. फर्स्ट ल. सेकेन्ड ल यसरी लेख्ने incident ray. Incident ray means coming ray, angle made by the incident ray with the normal, angle made by the reflected ray with the normal, angle of refraction. See, first law, 3 laws of reflection of light. Number 1, when a ray of light is incident at 90 degree, it is reflected at 90 degree. When it comes at 90 degree, it is reflected at 90 degree. 90 degree में आयो भने 90 degree में फर्किन्छ यस्तो किसिमले. See, first law. Second law, the incident ray, the reflected ray and the normal all lie in the same plane. The incident ray, in this case AO, the incident ray, the reflected ray and the normal to the point of incidence the incident ray, the reflected ray and the normal NO to the point of incidence all lie in the same plane. AO, BO and NO lie in the same plane. Another third law is the angles are equal. The angle of incidence, that is I, is equal to the angle of reflection R. Angle I equal angle R. Or generally we write I equal R. There are 3 laws. First law, if a ray is normally incident, it is normally reflected. 90 degree में आयो भने 90 degree में फर्किन्छ त्यही बाटो. It retraces its path. First law. Second law, the incident ray, the reflected ray and the normal all lie in the same plane. Number 3, the angle of incidence I is equal to the angle of reflection I. The angle made by the incident ray with the normal is equal to the angle made by the reflected ray with the normal. These 2 angles are always equal in case of regular reflection, but in case of irregular reflection the angles are not equal. Question number 3, laws of reflection of light, because it is very necessary to understand the differences between reflection and refraction. It is in class 7. 7 मा छ र 7 मा भएकोले यो पढ्नु पर्ने हुन्छ. Now, question number 4. Laws of refraction now. Not reflection, refraction. Question number 4. Write 4 laws of refraction of light with ray diagrams. See, actually, what is the difference between reflection and refraction? Reflection मा यस्तो हुन्छ, यसरी आएको लाइट यसरी reflection, but in case of refraction either bending of light यसरी जान्छ अथवा यसरी आएको लाइट bending of light. You two cases, refraction, but it is reflection. That is the main difference. So to get the difference, I have written in question number 3 laws of reflection, question number 4 laws of refraction of light with ray diagrams. First of all, I am going to write down this without bending. What is the difference? In case of laws of reflection of light, it shows laws of reflection. It is not refraction. यसरी आइरहेको लाइट हेर्नु त, यसरी आइरहेको लाइट यस्तो भयो भने this is the reflection, but this is the case of refraction of light. When a ray of light is normally incident, it is normally refracted without bending. First law. Second law. I, this is R, this is rarer to denser, rarer medium to denser medium. Now, denser medium to rarer medium, denser medium to rarer medium, denser to rare. यो एंगल यतापट्टि होइन, यतापट्टि बन्नुपर्छ. एंगल अफ इन्सिडेन्स I, एंगल अफ रिफ्र्याक्सन R. What is the first law? First law. When a ray of light is normally means at 90 degree incident, it is normally refracted without bending. If a ray comes at 90 degree, strikes at 90 degree, it goes straight. सीधा जान्छ. 90 मा आयो भने यो लाइट सिधै जान्छ. फर्स्ट ल. अर्को सेकेन्ड ल चाहिँ angle of incidence is not equal to angle of refraction. Just like in reflection, the angles are equal, but here angles are not equal. So it is not necessary to write down I is not equal to R. You लेख्नु पर्दैन. See, the incident ray, the not reflected, refracted ray and the normal to the point of incidence all lie in the same plane. All lie in the same plane. The incident ray, the refracted ray and the normal to the point of incidence all lie in the same plane. Second law. Third law, see, rarer to denser towards denser to rarer. Okay. To understand, I write denser to rarer away technique. With I need to write down the technique and you just copy of this from here. Denser to rarer away, rarer to denser towards. See, third law. If you forget the rule, tensor to rarer away, rarer to tensor towards. You start a sentence. You write down the sentence. Tensor to rarer away. How to write down? dr away if a ray passes from a denser to a rarer medium, it is bent away from the normal. If a ray passes from denser medium to a rarer medium, it is bent away from the normal. If a ray passes from a rarer medium to a denser medium, rarer medium to a denser medium, thin to thick, what happens? Tensor ke jata hai. It is bent towards the normal. Towards the normal. The first law, if a ray passes at 90 degree, it is refracted at 90 degree. Second law, the incident ray, the refracted ray and the normal to the point of incidence all lie in the same plane. Third law, denser to rarer away, rarer to denser towards. If a ray passes from a denser medium to a rarer medium, it is bent away from the normal. Denser बाट rarer तिर गयो भने thick बाट thin medium तिर गयो भने रे टाढा टाढा भाग्छ. It is bent away from the normal. Rarer बाट denser तिर आयो अथवा thin बाट thick तिर आयो भने light normal तिर मानिन्छ. If a ray passes from a rarer medium to a denser medium, it is bent towards the normal. First, second law, third law, and fourth law, which is called Snell's law. Fourth law is Snell's law. Snell's law. First of all, I write sin I by sin r equal mu. See, a constant refractive index. See, if you forget the language, it is very helpful. Sin I by sin r equal mu. You can just write down the sentence if you know this relation. So this relation is very important. Sin I by sin r. This is the fourth law or the last law. Sin I by sin r equal mu. I for incidence, angle of incidence, r for angle of refraction, mu for refractive index. It is called refractive index. It is the ratio of sin I by sin r. How to start the language? Snell's law. Snell's law states that the ratio of the ratio of the sine of the angle of incidence, the ratio of the sine of the angle of incidence to the sine of the angle of refraction, that is R, for any two given mediums is constant, called the refractive index mu. First law, second law, fourth law, Snell's law, sin I by sin R equal mu. It states that the ratio of the sine of the angle of incidence to the sine of the angle of refraction for any two given mediums is constant, and that constant quantity is called the refractive index denoted by mu. यसलाई लेख्ने तरिका, यसलाई कसरी लेख्ने भन्दा यो बनाउने तरिका, यसलाई बनाउने सिधा use a pencil compass straight. Here rarer to denser, see rarer to denser, rarer medium to or denser medium towards another denser medium to a rarer medium. अब यहाँबाट डेन्सर टु रेयर, अब यहाँबाट डेन्सर टु रेयर यसरी गयो भने डेन्सर टु रेयर, यसरी डेन्सर रेयर मिडियम, डेन्सर मिडियम टु रेयर मिडियम, यसरी यहाँबाट फेरि डेन्सर टु रेयर, रेयर टु डेन्सर, रेयर to denser, suppose it is a rarer medium, if it is a denser medium, the rate goes towards the normal, rarer to denser towards the normal, bent towards the normal, denser to rarer away from the normal, and bending at coming at 90 degree, it goes straight without bending. If a ray is incident at 90 degree, it is reflected at 90 degree. If a ray passes from denser to rarer medium, it is bent away. If a ray passes from rarer medium to a denser medium, it is bent towards the normal. Rarer to denser, towards. Denser to rarer, away. So the technique to understand is this one. dr away and rd towards sin I sin r mu. See, denser to rarer away, rarer to denser towards sin I by sin r equal mu. So I have written 4 questions, and I have written the laws of reflection of light, 3 laws of reflection of light, and 4 laws of refraction of light. The first law seems to be very similar. The incident ray, the reflected ray, and the normal all lie in the same plane. That is in first law of reflection of light, not refraction, reflection. But here you have to write down the incident ray, the refracted ray, and the normal to the point of incidence all lie in the same plane. There is one difference. Refracted ray, not reflected ray. In case of law of reflection of light, Snell's law does not hold. Reflection ma Snell ko law लाग्दैन, refraction ma लाग्छ. Snell's law is applicable only in case of refraction of light, but Snell's law is not true when when a ray is normally incident. If a ray is normally incident or incident at 90 degree, Snell's law does not hold. रे 90 डिग्रीमा आएको खण्डमा स्नेल्सको ल लाग्दैन. यो sin I by sin R equal mu. This much for today.